Okay, so when you hear the word infrastructure, you probably think of, massive steel bridges, sprawling highways, maybe a bustling seaport. But today, we're redefining that entirely. Modern infrastructure is no longer just concrete poured on the ground. It stretches deep beneath our oceans and reaches all the way up into the stars. The physical world is completely merging with the digital and the celestial, creating an entirely new global network.
Okay, let's dive into this. Here is our agenda for today's explainer. Redefining modern global infrastructure. The Belt and Road, the digital Silk Road. Vulnerabilities under the sea. The race for orbit, and finally, who controls the network?
Section 1. Redefining modern global infrastructure. Redefining connectivity.
So I really want you to ask yourself, what actually comes to mind when you hear infrastructure today? The wild reality of the 21st century is that the absolutely most crucial infrastructure running our world right now is largely invisible. It's buried deep underground, it's resting quietly on the pitch-black ocean floor, or it's literally flying hundreds of kilometers above our heads. To truly grasp modern geopolitical and economic power, we have to look at these hidden, unseen layers. Let's ground this with the Belt and Road Initiative, or BRI. Launched by China back in 2013, this is a massive global strategy connecting over 140 countries. But here's the thing. This isn't just about paving over ancient trade routes anymore. It has morphed into a complex, three-dimensional strategy that encompasses physical, digital, and space-based infrastructure.
Moving to Section 2, the Belt and Road, focusing on the physical foundation.
$1 trillion. I mean, the scale of investment we're talking about here is just astronomical. Estimates project that by 2025, China will have initiated or completed Belt and Road projects worth a total of $1 trillion. A massive chunk of those funds goes straight into traditional infrastructure. We're talking heavy transport like roads and railways and huge energy production facilities. This is basically the physical anchor of global connectivity, establishing very tangible supply chains all across emerging economies.
And this brilliantly illustrates the geopolitical dynamic at play. Because make no mistake, infrastructure is a highly competitive space. In direct response to the BRI, the G7 launched their own counter-initiative called the Partnership for Global Infrastructure and Investment, or PGII. They are mobilizing $600 billion in loans and grants specifically focused on sustainable, quality infrastructure projects in developing nations. What we're seeing is both initiatives demonstrating a really serious, well-funded commitment to shaping the physical arteries of the global economy. They are essentially offering developing nations two different frameworks and sets of standards for their infrastructure needs.
Which brings us to Section 3, the Digital Silk Road, building the digital arteries.
Announced in 2015, the Digital Silk Road targets the infrastructure gap with bytes instead of bricks. It's all about exporting Chinese technology across a variety of sectors, rolling out 5G networks, artificial intelligence capabilities, cloud computing, smart city tech, massive e-commerce platforms, and subsea fiber optic cables. Think of it as a giant overarching umbrella that aims to bring developing markets directly into a unified digital ecosystem.
Now, what's really interesting to look at here is how the Digital Silk Road perfectly illustrates vertical integration. It doesn't just stop at laying down physical 5G networks and fiber optics on the ground. It actually moves all the way up the stack. It builds the foundational services like smart cities and data centers, which then completely paves the way for over-the-top platforms like e-commerce and fintech. It's not piecemeal. It's a complete, deeply integrated technology ecosystem.
Let's dive deeper. Section 4. Vulnerabilities under the sea. Examining our fragile ocean backbone.
95%. That figure is just staggering. 95% of all intercontinental data traffic travels through submarine communication cables. Right now, as we speak, there are about 1.4 million kilometers of these cables just resting on the seabed all across the globe. We love to think our data is magically floating up there in the cloud, right? But the reality is that the cloud is entirely dependent on physical cables that are roughly the thickness of a garden hose. These cables are literally the fragile, physical backbone of the world economy, carrying absolutely everything from your favorite streaming video to high-frequency global financial trades. But here is an incredibly fascinating detail that fundamentally changes how we need to view these cables. Through a breakthrough technology called distributed acoustic sensing, or DAS, navies in the US and the EU are actually figuring out how to turn these communication cables into vast, passive underwater sonar networks. By sending laser pulses down the fiber optics, they can physically detect the vibrations of submarines and surface ships above them. This absolutely highlights the dual-use nature of this infrastructure. It's not just commercial anymore. It is highly strategic and inherently military. And because it's so vital, protecting it is complex, it's incredibly expensive, and it leaves us wide open to hybrid warfare vulnerabilities. But this infrastructure race isn't confined to the Earth's surface.
Let's move to and see how this builds in Section 5, the race for orbit, focusing on satellites and space.
Just as those cables completely dominate the sea, satellite megaconstellations are starting to dominate our skies. Take a look at the chronological acceleration of China's Guowang, which translates to national network. Back in 2016, a space information corridor was officially added to the Belt and Road. Fast forward to 2020, and they file with the International Telecommunication Union for an astonishing 12,992 satellites. In 2021, the state-owned China Satnet was formed to centralize the entire effort. And bringing us right up to date in 2025, we are actively seeing Long March rockets launching operational satellites. We've watched this evolve incredibly fast from just a policy concept on paper to actual physical rockets in space.
To really understand this landscape, we have to compare Guowang side by side with its primary competitor, SpaceX's Starlink, because they represent two completely different models. Starlink relies heavily on a commercial enterprise model, prioritizing fast iteration, mass adoption, and a low-latency focus almost entirely in low Earth orbit. Guowang, conversely, is a highly state-led endeavor. It's focused on security, tight state control, and digital sovereignty. It actually utilizes a multi-tiered orbit design, putting some satellites at 500 kilometers and others way higher up at 1,145 kilometers, all to ensure stable, broad coverage and strategic redundancy. So we're looking at two very distinct approaches to blanketing the globe in connectivity.
Which leads us to our final part. Section 6, Who controls the network? The reality of digital dependency.
So the crucial point is understanding this whole concept of digital dependency. We are currently seeing the rise of massive initiatives like China's Skynet, which literally aims to vertically link space, air, and ground-based communications into one giant, resilient, secure system for global data flows. And here's the reality. When a nation adopts this level of integrated infrastructure, whether that's using Chinese-built ground stations that talk directly to Guowang satellites or Western undersea cables seamlessly linked to commercial server farms, it creates intense digital dependency. Adopting a country's physical and digital infrastructure heavily incentivizes you to also adopt their norms, their tech standards, and their specific rules for data governance.
So, as this digital dependency continues to grow across these hybrid cable and satellite architectures, we really have to stop and ask, what are the long-term implications of a bifurcated global digital ecosystem? Think about it. If half the world runs on one highly integrated stack of infrastructure and the other half runs on an entirely different set of standards, who truly controls the global network of the future? It's a huge puzzle. Thanks so much for joining me for this explainer today. Keep asking those big questions.